Hello everyone and welcome to another math tutorial. In this video we continue our exploration into circles by discussing the angle relationships in circles. These angles are going to be formed by chords, secant lines, tangent lines, and the angles can be either inside the circle, outside the circle, and also on the circle. Alright, the first theorem is called tangent and intersected chord theorem, and it's very similar to something we did in the last video where we discussed inscribed angles. This theorem says that if a tangent and a chord intersect at a point, so here we've got a tangent line, we've got a chord, they intersect at a point, that point is on the circle, then the measure of each angle formed is half the measure of its intercepted arc. Okay, so using the picture as an example, if I look at angle 2 right here, the sides of angle 2, this side and this side, where those sides hit the circle, intercept this arc. Okay, so this theorem is saying that angle, well, let's go with the arc. If the arc is, say, x degrees, then the angle is going to be half of that arc. All right, how about a couple of example problems to illustrate that theorem? In both examples, directions state that line M is tangent to the circle. We're asked to find the indicated measure. So in this first example on the left, we want to find the measure of angle 1. Notice that angle 1, the sides of angle 1 intercept an arc that is 210 degrees. Angle, or the measure of angle 1, has to then be half of that intercepted arc, half of 210. So the measure of angle 1 equals 105 degrees. In the second example, we're actually trying to find the measure of an arc. So we're going to use this theorem kind of conversely. Flip it around. Here we're trying to find arc RST. So RST is this arc right here. I have the value of the angle that intercepts the arc is 98 degrees. So here the measure of arc RST needs to be twice as much as the measure of the angle. So double 98, which is 196 degrees. All right, our next theorem deals with angles that are formed inside the circle, and that's important to make this distinction between what's going to come next when the angles are on the outside. Angles formed on the inside of the circle is formed by two chords that intersect somewhere in the circle. This theorem says that the measure of each angle is half the sum of its intercepted arc and the intercepted arc of its vertical angle. So there's a lot going on there, and I'm going to highlight those on the picture here. So let's just pick one of these two angles. I'm just going to pick angle 2 right here. So angle 2 formed by these two sides, and angle 2 intercepts this arc, BC. Now, you also need the vertical angle of angle 2, and the vertical angle is formed by these two sides, right? As the vertical angle is right here. The vertical angle, it intercepts that arc. Well, this theorem tells us that that angle, angle 2, is equal to half the sum of its intercepted arc, BC, plus the vertical angle's intercepted arc, AD. So essentially what we're doing is we're going to add the two arcs together. We're going to divide by 2. That's kind of the computation, the simple computation that'll get us to the measure of that angle on the inside of the circle. All right, let's try a couple problems, example problems to illustrate this theorem. First example problem, we're asked to find the value of x. So I'm looking for this angle right here. I'm going to use that angle and then also the vertical angle to that angle. And then I want to look at the arc that the angle intercepts, which is this one right here, and the arc that the vertical angle intercepts. So that arc there. So we're going to use both of those two arcs. The value x is going to be half of 156 plus 130. So that's going to be half of 286, and so x is going to be 143. All right, the next example shows a very similar image. We've got lines that are intersecting on the interior of the circle, so that's how it's kind of the same. What's different about it is that the variable that we're trying to find is on one of the arcs and not one of the angles. But because it's the same type of setup as far as what's given, we're going to solve this in the same manner as we solved the last one. Now the arc that we're trying to find y is on this arc right here, AB, which is this angle here. The vertical angle to that right here intercepts this arc, 95. So I need, if I'm going to use these two arcs, then I need one of these two angles on the interior. It doesn't matter which one because they're vertical angles, and vertical angles are the same. They're congruent. So whichever one I want to find is fine. So let's just say I find this angle right here. That angle, because it makes a linear pair with 102 degrees, I can find it by doing 180 minus 102, which makes this angle 78 degrees. All right, with that in place, we're ready to go. And just like we did in the last problem, the angle on the interior of the circle, in this case, we know that it's not x like in the last problem. So 78 is equal to half of its intercepted arc plus its vertical angle's intercepted arc. With the problem presenting this way, I'm going to solve it by multiplying both sides by 2 to get rid of that 1/2. So that gives me 156 equals 95 plus y. To solve this, we're going to have to subtract 95 from 156. Doing that gives me 61 equals y, or y equals 61. The next theorem deals with angles that are formed outside of the circle. So you can see from the images how this looks a little bit different. We don't have the angles formed on the inside by intersecting lines, but instead we have either secant lines or tangent lines, or the combination of them both, forming angles on the exterior of the circle. Now this is really similar to what we did on the last two examples with the last theorem. So this says we have that angle that's formed on the outside of the circle, then the angle formed is half, so that's the same. The difference, so that's a little bit different, half the difference of the measures of the intercepted arcs. Okay, so let's just take one of these pictures to kind of illustrate and write a formula, if you will. I'll just take the last one, but we can do this with all of them. So here we've got angle 3, and notice the sides of angle 3, they intercept this arc, and they intercept that arc. Well, this theorem says that the measure of angle 3 is going to be 1/2 of the difference of these two arcs. So I want the measure of arc xy minus the measure of arc wz. You have to make sure that when you do this difference right here, this is super important, that this first arc is the larger arc and this one is the smaller arc. You are subtracting them, so you want to make sure that when you do this subtraction, this difference right here, that you have a positive number. And the only way that's going to happen is if you do the bigger number minus the smaller number. So in effect, it's always going to be that way. It's always also, if you think larger, smaller, it's always going to be subtracting the arc that is furthest away from the angle minus the arc that's closer to the angle. And that'll always accomplish this as well. So let's try this with a couple of example problems. All right, our first example problem illustrating this theorem. We've got an angle here, x, which is on the exterior of the circle. The sides of this angle are intercepting this arc right here, and then also this arc. This arc right here is not going to be used, okay? It's outside of the sides of the angle. So we want to use those two arcs that we see the angle form. Well, that theorem says that the exterior angle x is going to be half of, you always want to do the larger arc first, minus the smaller arc. So x is going to be half of 178 minus 76 is 102, and then half of 102 is 51. Final example problem of the video. This one, you can see the same kind of setup. We've got an angle that's on the outside of the circle. It intercepts two arcs, this 44-degree arc and this A-degree arc. The difference in this problem and the last one should be obvious looking at this is that the variable is on one of the arcs and not the angle. But it doesn't change how we set up the problem. The setup of the problem is always the same, and this is the way it goes. You want the measure of the exterior angle equal to half, and now I want the larger arc, which is A, minus the smaller arc, 44. Now we do have to solve this equation for the A. The A is on the right hand side with all this other stuff, these other numbers, so we have to solve this. I will begin by multiplying both sides by 2 to cancel out the half. So we've got now 60 equals A minus 44. We'll add 44 to both sides, and we get A equals 104. That's it. As always, with any of my videos, if you have any questions, please comment down below and I would be happy to answer them as soon as I see them. If you found this video helpful, please give it a thumbs up to support the channel. I appreciate it, and we'll see you in the next one.